Hi everybody. Let me make sure my volume's up. I'm gonna do a little demonstration to talk to you and move into the topic of gravity in the solar system. So we're gonna start kind of basic, and I'm gonna show you a few things. So I'm in my daughter's room, and it seemed like a good spot to get away from everybody. But so this is a ball that's going to represent. It's like a little bungee jumpy ball, but we're going to use it this way. This is a ball that's going to represent the Earth, okay? Then this ball's a lot smaller. You compare it. What do you think this is going to be? And I'll give you a hint. It's not Pluto. It's not really another planet. If you said the moon, perfect, okay? So we have the Earth. We have little Astro Rabbit here. And Astro Rabbit is going to stand on the Earth real quick, okay? Because he's an astronaut, or she, or whoever. You can probably still hear my kids in the background. They're downstairs and being crazy, so just kind of note that. But what I wanted to go over with you, hold on while I kind of adjust my thing here. We need to talk about, I wanted to get rid of that on my screen. Okay. We need to talk about really quick what gravity is and mass to remind you. Okay. So when we talk about gravity is going to be a force. Okay. You learned about forces in the force of motion unit, like what was it, unit 3 or 4? And it tries to pull two objects toward each other. So that's gravity. I mean, if you think about it, we are on Earth. And if you were to jump up and down, you keep going back really to the same spot, right? You keep getting pulled down back to Earth. So anything that's going to have mass, remember when we talked about mass, that was in the density unit way back when, maybe like late September sometime, throughout like early October or something like that. But mass is how much stuff we're made out of. So unless we go on like a crazy diet or something, how much stuff we're made out of is going to stay the same. All right. That doesn't change. All right. So anything that has mass, like me, you, this rabbit, this ball, anything that has mass has a gravitational pull. All right. Which means the more massive an object is, the stronger its gravitational pull is. All right. Now I'm going to pause really quick because my kids are going crazy. They're having lunch downstairs and being nuts, so hold on. Alrighty, so I'm back where we left off. I was talking about that gravitational pull. So with mass, and just to let you know, the more massive an object is, like Jupiter, the stronger its gravitational pull is. Earth's gravity is what keeps you on the ground and what causes objects to fall, okay? To remind you about mass is going to be a measure of the amount of matter in an object. Mass is usually measured in grams, like grams or kilograms. Gravity, the force of gravity, we usually measure it like in pounds, but the force is in newtons. So we're going to be looking at newtons this week, and later when we do your lab outdoors later this week. So an object's mass is constant in all circumstances. But it's kind of different from weight. So weight depends on gravity. So here's an example. Now, Mr. Rabbit here, he has not gone on a crash diet, nothing like that. He's been the same for a long time. All right. He's made of so much stuff. So therefore, Mr. Astro Rabbit here is going to be the same no matter what. So his mass is the same no matter if he's here, Jupiter, Pluto, wherever. Okay? Now, if he jumps up, where's he going to land? He's going to land back where he came from because of that gravitational pull that's pulling him down because of Earth's gravity, and he's going to land there. If he's off in, I don't even know where this is on the globe, but let's pretend it's like China or something. If he jumps up, he's going to land back in China. Now, I mean, over here, where is this? Like Australia or something, or South America, something like this. So if he jumps up, he's going to land back down. This is gravitational pull, okay? Wow, that was a big scream. you can tell the kids are terrorizing each other downstairs, and that's part of having multiple siblings. But so kind of ignore that if you can. But anyways, that's just proving to you that this object's mass, like the Earth, has a massive gravitational pull on this rabbit. So therefore, it's pulling him down. So the mass of this planet is crazy. The mass of the planet is not changing, staying the same. The rabbit, Astro Rabbit here, is not changing. His mass is the same. But this has a crazy gravitational pull on the rabbit, and it's going to pull him down, but it goes in the same spot, okay? Now, you guys can kind of estimate if I use the moon now, and Astro Rabbit's on the moon, his mass hasn't changed. He's still the same as he was on Earth, okay? And just to let you know that this planet, not planet, but the moon, his mass is not as great as the Earth here, okay? So if Astro Rabbit jumps up, he's eventually going to come down, okay? Now, this is because the gravitational pull that this planet has on the rabbit is not as strong as on the Earth. So he'll eventually come back down and land in his spot, no matter where he is on the moon, but it's not going to be as rapidly fast as it is on Earth, okay? So just remember that no matter where you are in space, there's always going to be gravity. So for an example, if you're on Jupiter, Jupiter's going to be like 5 times bigger than this ball to represent it. I would need one of those massive, massive balls. But if that was Jupiter, it'd be really fast because Jupiter has a mass that's so crazy big. So its gravitational pull is going to be crazy big, pulling you down. And therefore, your weight, his mass is going to be the same on Jupiter. Because no matter what, he's still made of the same stuff. But his weight will change on Jupiter from Earth to the moon, okay? Like it's going to be different because of that gravity, that gravitational pull, and that corresponds to your gravity. That mass of each planet corresponds to the gravitational pull, which then determines your weight. So just giving you an idea of what we're talking about here when we're moving into gravity, this unit, and gravitational pulls and all that good stuff, okay?